Have you ever wondered why those desserts at high-end hotels look like completely flawless, but the ones we try to whip up at home just don't? Well, let's dive right into this. Today, we're unlocking the ultimate secret of the professional pastry kitchen in this explainer. We're looking at the actual literal science of texture and how you can absolutely master it.
Think about it. We've all been there, right? You find this amazing recipe online, you gather up all your ingredients, you follow it to the letter, but then when it's finally time to serve, disaster. That gorgeous mirror glaze you spent literally hours on just runs right off the sides of the cake. Where that beautiful, airy mousse, it collapses into a sad, deflated puddle on the plate. It is so incredibly frustrating. You pour your heart into it, and it just doesn't survive the trip from the mixing bowl to the dining table.
And that brings us to the real divide, the home recipe, what we make at home, versus hotel chemistry. Because here's the truth. The difference between a total culinary masterpiece and a collapsing failure, it actually isn't the recipe itself. It's not like they have magical sugar or super fancy cream. The secret lies entirely in chemistry. Specifically, it's about targeted chemical solutions provided by what professional chefs call silent heroes. Yep, today we know them as stabilizers. They're the invisible framework holding the whole shebang together.
Section 1. Pectin NH, the thermal shapeshifter.
I absolutely love talking about this one because it genuinely behaves like a culinary superhero. It's a real game changer. It completely transforms how we construct those beautiful layered desserts, shiny glazes, and vibrant fruit fillings. And why? Because this stabilizer is thermally reversible. So, what does that actually mean for us in the kitchen? Well, it means you can melt it down when heated and it'll set perfectly when cooled. And the crazy part, it can do this repeatedly, over and over, without losing any of its structural integrity. Imagine a fruit jelly that you can melt into a liquid, pour precisely over a complex cake, and just know it's going to set perfectly smooth once again. That is the magic of Pectin NH. It gives you infinite second chances.
But to actually harness this power, you've got to follow some strict kitchen rules. Okay, step 1. You must dry mix your Pectin NH powder with sugar. Step 2. You incorporate that dry mix into your liquid base. Listen, you never, ever just dump the raw stabilizer powder straight into your wet ingredients. No way. If you do, you'll immediately get a lumpy, totally unusable mess. So remember, dry mix with sugar first to disperse those tiny granules, and then you incorporate it.
But wait, let's slow down for just a second here, because this is where the real magic happens. The absolutely crucial point is this highly specific temperature. When you add your pectin and sugar mixture to your liquid, that liquid needs to be at exactly 40 degrees Celsius. Actually, let me emphasize that. Not room temperature, not boiling hot. 40 degrees is the critical secret to success here. It ensures the stabilizer hydrates perfectly without clumping up. It's just pure precision at work.
Section 2. Xanthan Gum, the silky secret.
So, if Pectin NH is your structural builder, Xanthan Gum is your ultimate textural enhancer. It has two massive superpowers. First up, it creates this incredible, silky texture for sauces and mousses. It binds the water in your mixture, which stops any of that gross weeping or separation, and creates this luxurious, velvety mouthfeel that just coats the tongue perfectly. But the second point here is honestly even more vital. Zero taste alteration. Xanthan Gum does all this heavy lifting completely invisibly. It doesn't mute the delicate notes of, say, a vanilla bean, and it certainly doesn't dull a rich chocolate. It completely preserves your original flavor profile while elevating the texture to a totally professional standard.
Section 3. Siphon Science. N2O gas pressure.
All right, let's step away from the powders for a moment and shift our focus to the physical science of culinary hardware. Because this is exactly where chemistry meets physics. You see, N2O gas pressure acts as a really powerful physical mechanism. When you charge a culinary siphon with N2O, that gas dissolves directly into the fat and water of your liquid dessert base under extreme pressure inside that little canister. And then, when you finally press the trigger and release that mixture out into normal atmospheric pressure, boom! That dissolved gas rapidly expands. This physical reaction literally forces an incredibly light, airy structure right into the mix. It quite literally transforms a dense liquid into a floating cloud in a fraction of a second. It's so cool.
Section 4. Chemistry rules, precision, and acid.
But here's the catch. And yeah, it's a pretty big one. These superpowers, whether it's the thermal shifting of Pectin NH, the silkiness of xanthan, or that rapid aeration of a siphon, they are entirely dependent on strict chemical rules. Take Pectin NH, for example. As you can see, it absolutely requires an acid balance to form that beautiful gel we were just talking about. For it to maintain its pH balance and, actually activate, it needs a highly acidic environment. That is exactly why you so often see it paired with bright acidic ingredients like yuzu or lemon. If you try to use Pectin NH in a completely neutral environment, the chemistry just fails and the gel simply won't set. The chemistry dictates the recipe, not the other way around.
Chemistry really does change everything, doesn't it? It completely turns our cooking from simple guesswork into absolute mastery. By understanding these silent heroes like Pectin NH and Xanthan Gum, and by mastering tools like the siphon, you literally hold the power to control texture. So the big question I want to leave you with is, what dessert are you going to stabilize today? Keep experimenting, keep learning, and I will see you next time.